easier than graphic.
That's
Well,
fair.
I'll just say it like this. All right.
I know.
Well, that's what it was exactly. Okay. So I am recording, so be on your best behavior. Go grab the sheets and hand them out. We're going to start off this chapter. It starts off not the worksheets, but the handouts. Starts off fairly simple. If you have good recall from pre-algebra, this will seem very familiar because it's literally the same stuff you learned in pre-algebra. So we have a little bit of a review to start off with. I do have all your tests graded for period 7. By the time you watch this video right here, I will have your tests graded in the grade book. For those that still need to do the makeup for that test, get with me. We'll talk about when you're going to do that. Remember, it's got to be done by Friday. The quarter ends this Friday. Okay. Yeah, this Friday is the end of the quarter. All right. So here we go. Here is the sequence of events for this chapter. Notice it's going to get broken up with spring break. I always do this. If it gets broken up with spring break, the day that we get back from spring break, I do a review, and then we'll move on. There aren't too many sections left after 10.7. I think one more section, and then the test.
Oh, good.
All right. Here is your homework. It is a worksheet. Copy that down, please.
What is exactly the worksheet?
Well, people put it in their planner.
Raise your hand if you actually use your planner. I know exactly where mine is, but it's on mine.
It builds up. It builds up.
I think mine.
Okay. I need to do this quietly, please. Quietly. Thank you. Sorry.
Mr. Shodia.
Okay. Okay, so it is a worksheet. This is probably 5 to 10 minutes worth of work, so it's not too challenging. Let's see what look at the sheet I just handed you. Let's see what your recall is from the stuff that we did last year. All right, this was Mr. Murphy taught you this, right?
No, it was Riki actually.
Or yes, if you were homeschooled, then you taught you something. All right. I have a way of teaching this. I'm pretty sure Mr. Murphy did it this way. There's lots of techniques to teach this. I have pretty good success with this method. Most kids like it. I will say this, you just have to be able to read. Okay. All right, so here we go. There are 4 things. There's the objectives. I'll repeat them after we get to the end of objective. All right, so this entire chapter is inequalities. Inequalities are, well, they're not equations. So I start off this with a contrasting inequalities with equalities. We just finished up the equalities. So let's contrast what an inequality is with an equality. So what is an equality? Anybody? Well, what is an equation? Something with an equal sign. Literally, we know equations simply because they got an equal sign. So if you don't have an equal sign, guess what you are? You're not an equality, and we give that the name of equal. We could say not equality. We chose the word inequality. So the actual definition of an inequality is you're not an equation. You're an inequality. Okay? That's not the formal definition. We'll talk about that here in a second, but that's the basic idea. If you're not an equation, you're an inequality. Except we got to add one extra concept because we have a thing called an expression. An expression is not an equation. It's also not an inequality. So what I have to add to this definition of if you're not an equation or an inequality is this. An equation gives you the relationship between the two sides. And the two sides are made up of expressions. I got an expression on the left-hand side, LHS. Our book will use LHS and RHS. And I have the expression on the right, the right-hand side. And what an equation does is it makes this basic observation. It means that the value of the stuff that I just put a box around, the 2 plus 6, finish the sentence, is equal, has the same value as the stuff on the other side. This is literally what an equation is. It takes 2 expressions, and it doesn't say the numbers are the same. Well, the numbers are clearly not the same. But it says the value of the left side is equal or has the same value as the value on the right side. Okay, I just went into great detail to explain what an equation is. So what's an inequality? Well, if an equation says that the stuff on the left not the same, but its value is the same as the stuff on the right. So what's an inequality?
Stuff on the left is greater than or or less than the stuff on the
And that's how we're going to define an inequality. Okay. So if that's an equality, then we define an inequality as we still have a left-hand side and a right-hand side. We still have stuff, but as Chris just said, it's not going to be the same values. One side is going to be bigger than the other side, except we make it even more complicated because we also have these two signs called less than or equal to. So it turns out that in some inequalities, okay, this isn't good because we can actually say that the left-hand side is the same as the right-hand side. But that's when we use these specific signs, the less than or equal to, or the greater than or equal to. And you should be familiar with all those signs. So here are two expressions, left expression, right expression. Are they equal to each other? If they were equal to each other, we could use an equality symbol. But since they're not equal to each other, well, then they live in the inequality world. And by definition, an inequality is it compares two expressions, the expression on the left, the expression on the right, without the use of an equal sign. So we need other signs. So guess how many signs we have? Turns out we have 5, but we're only going to deal with 4 today. The 5th one is an equal sign with a slash through it. That means does not equal. But does not equal doesn't give me any information. The other 4 symbols that you're familiar with give me information, and it tells me which side is bigger. Okay, way back in 4th grade, maybe 3rd grade, you learned this. Which side is always the biggest side?
The one with the bigger number.
Okay, so what part of the symbol always faces the larger value?
The alligator mouth.
Yeah, alligator mouth.
I don't know which math teacher came up with the alligator thing, but that's the thing. Everybody familiar with the alligator thing?
No.
The opening of the mouth. If you can imagine the inequality symbols, okay, let's get to that. This is the less than symbol, the one right there. So the alligator mouth, I'm sorry, video people, you can't see what I'm doing here. But if I put teeth right here, and I drew the snout and the eyeball, well, there's your alligator.
That's a very nice alligator.
There's your alligator.
Yeah.
I need an eyeball, don't I?
For the rest.
So the mouth, it looks like, I'm not an artist, so that's horrible. But it looks like a shark, doesn't it?
Yeah.
It's beautiful.
No, it looks like a tadpole with legs.
Shark. Okay. But the opening will always face the larger value. I don't care whether it's less than, greater than, less than or equal to, or greater than equal to. The opening of that V, the sideways V, faces the largest value. The largest value could be on the right, it could be on the left, it could be on either side, but the opening has to face that. Okay. So this particular one, since 1 plus 4 is smaller than 10 plus 11, then the opening needs to face the 10 plus 11, the opening of the V. And then I'm going to stop talking about that because that should be prior knowledge information. Yes?
Yeah.
Okay. So quick notes. This is the only note. It's one note. Quick note. When you have, or recall that when you have equations, if I write, this is not an inequality, this is an equality. If I write x plus x is equal to 4, true or false? True. Is this the only way we could write that? There's another way we could write that. I could also write, Caitlin said I could write 4 equals x. Are these the same or different?
The same.
They are exactly the same. Is the symbol between them the same or different?
Same.
But guess what happens in an inequality world?
It would be.
It doesn't happen, right?
Greater than or equal.
So in the inequality world, this is just a statement, x is less than 4. If you want to flip it around, guess what you actually have to do? I mean, notice in the equality world, I just flip the x and the 4, right? I put the x on the left on the first one, the 4 on the right, and I flip around. I didn't change the symbol.
You have to flip everything.
If you do it in the inequality world, you can't just flip them around like that. You actually have to flip everything, including the sign. Does that make sense?
Yeah.
Because the opening has to face the larger thing. Okay? All right. So that's the only note I need you to remember. This is technically box 1. And box 1 is this concept right here is that in the equation world, and you saw me do this plenty of times solving equations, I put the x wherever I wanted to. I just flip things around. But if you go to the inequality world and you flip things around, you got to flip the sign as well. Does that make sense?
Sure.
Okay, that's box number 1. All right. So it's the same inequality, but it's a different inequality symbol. By the way, it's not something I want you to write down. you can read equations or inequalities right to left or left to right. If you read the top equality from left to right, it says x equals 4, right? If you read this one from left to right, it says 4 equals x, but guess what happens if you read it from right to left? It still says x equals 4. Same thing with the inequality world, except you read the symbol backwards. The left one right here, x is less than 4, but if you read the same thing left to right, this says 4 is greater than. But if you read it right to left, it says x is less than 4. So it turns out the same inequality on the left, as long as you read it in the opposite order, is exactly read the same way. Have I confused you?
No.
Okay. All right. So x is less than 4 or 4 is greater than x is how it will be read from left to right. Last thing is this. This always confuses people. Like, people will be able to do the math for inequalities, but if I just have the symbol floating there all by itself, and I ask you what symbol it is, all of a sudden people lose their brains and they can't tell me what the symbol is. So if the symbol is just floating there, there's no numbers or anything by itself, then you just read the symbol from left to right. Always read the symbol from left to right if it's the symbol floating there. What floating, I just mean the only thing there is that. So then we must read this from left to right. This is the, there you go, right? Notice that if I read this from the second inequality here from right to left, it says x is less than 4, although the symbol itself by itself is actually the greater than symbol. Okay, a lot of kids get confused by that. All right, sorry, period 7, you didn't get to see what I wrote on the board. It'd make more sense if you saw that. All right, we're going to play 4 games today. The first game today is I'm going to give you text, and you're going to write the inequality. Remember, this was lesson, I don't know, second or third lesson we did. I gave you text, and you wrote the expression or the equation. Now we're going to do the same thing, just with inequalities. The technique remains the same from chapter 1. You read it from left to right, and you write down the pieces that you see. All right, Luke, read the first thing and stop when you get to the first piece of information.
Okay, all real numbers x.
Stop. So all real numbers x is the first piece of information. Once you see this once, it should lock in your brain. Guess what they're saying there, all real numbers x?
Anything in front of x.
They're just saying x. So you write an x. So if you see the expression all real numbers x, they want you to write an x. Keep reading.
Less than or equal to.
Stop. Less than or equal to. Show me with your fingers what's that symbol.
Well, we got this and we got this.
So period 7, he gave me that symbol right there. So there's your less than or equal to. And the last thing is?
-7.
Okay, well, that one wasn't too challenging, right? And none of these will be that challenging.
Super difficult.
Okay. So x is less than or equal to -7. Yes?
Yeah.
Can these be more challenging?
Yeah.
And you will see them more challenging. All right, here's another one. All right. Kaylin, read. Stop. 6 less than. This is, remember, if you remember back to chapter 1, I said people make the mistake on what? Add, subtract, multiply, or divide.
Subtraction.
Subtraction is the one that everyone makes the mistake. 6 less than, guess how we're going to write that?
-6.
Yeah, that one is going to be a -6. So it says 6 less than a number k. So it's not -6 plus k. It's going to be k -6. 6 less than, I mean, subtract 6 from something. What are we subtracting it from? We're subtracting it from k. Subtraction is the one that always causes you a problem. And it's because how we write it in English. In English, I mean, from left to right, it literally looks like I should write 6 minus k, right? But if it's 6 less than, that's not +6, that's a -6. The other thing is this. What words are we using to write subtraction?
Less.
Guess what less than also means?
Division.
Right? This is the less than. Period 7, I'm showing the less than symbol. The less than symbol is also how we write with words subtraction. It's one of the many ways. So if they really want to be mean to you, they're going to write subtraction as the word less than and say, instead of saying subtracted from. 6 subtracted from a number k, chances are you're not going to make a mistake. But the kid that's not paying attention, they say 6 less than, they're going to want to write 6 and a less than symbol. It's challenging. The inequalities can be challenging in this case. Okay, greater than 13. Well, what I would say is this. If you are confused of whether 6 less than is a less than symbol, read the whole darn thing and see if it makes sense. Greater than 13, there's no other way to interpret that other than that symbol right there. Greater than 13. So if you're confused about the 6 less than, read the whole darn thing and see if you still want to go with it's a less than symbol. Make sense? All right, Kaylin, Abby, come on, pay attention. All right, here are some more challenging ones. Okay, all real numbers P, so we're going to write P. We're going to write P. Greater than or equal to, so we're going to write
This thing.
they're showing me the greater than or equal to symbol. 1.5. Okay, well, that one isn't very challenging. Where are the challenging ones? Oh, the sum of T and 7.
That's easy.
T plus 7.
Okay, maybe that isn't that challenging.
What's the symbol of -3?
And then that's that one.
So
Yeah,
are
so
there
that-
challenging ones?
No.
That
Oh,
one.
yes, there are. So let's look at the
Yeah, let's put-
challenging ones.
Oh,
Okay,
God.
so these are the challenging ones, and it's because they're going to have more than one operation. Okay. The quotient.
That's division.
Oh, that's division. How do we write division in algebra, though? How do we write division in algebra?
With a fraction.
Fraction bar, right? So the quotient of 6 next, and you're in luck. Quotient is the easy one. Quotient is always written. The first thing is the number on the top, the numerator, and the second thing is going to be the denominator.
That's so difficult.
So what am I going to write?
6 over x is less
Okay.
than 4. Negative.
This simple.
They're showing me the less than symbol and a -4. We're done. All right. Not too challenging, but there's a few of you out there that didn't want to admit that you forgot what quotient meant, right? Division symbol.
Don't look at me.
All right. Another challenging one. This is the most challenging one right here.
Okay,
Most kids can't get this in Algebra 1.
okay, well, 4x,
Wait, I would always start with what's written first.
okay, 5 more than.
Well, how do you write 5 more then?
That's fine.
Okay.
Plus
So
5.
5 more is plus 5.
4x is 5.
Parentheses 4x. 4 times x.
What is 4x?
So we could write 4 times parentheses x. We could also write just 4x.
That's what I
right?
said.
So where's the 4x going? To the left or the right of the 5?
Front
Run of it.
Okay. So there, keep going.
is
Oh, it's
Greater
greater
than.
than symbol 2.
2.
All right. So easy, medium, challenging.
Super challenging.
All right. All right. On your paper in front of you, box 2, you have 4 examples. All by yourself, do those 4 examples. Go. Go. Yes. Let me see your 4 answers. Bring it up here. You got one of them wrong, then no. You got one of them wrong. Which one do you think you got wrong?
Don't look fraction.
Which is the most challenging one?
The last one.
Think that one through again.
Okay.
That's the only one you got wrong. Last, where's your piece of paper? Here, get it out in front of you. We're doing the whole thing.
Oops, I did wrong symbol.
All right, here we go. Ava, first one. What did you write? Like this one's literally written this exactly the same way it's written, right? There's no misinterpretation at all. Very good. All right, what do you got, Caleb? Next one.
I got 4 plus y is less than x.
Okay, he wrote it exactly the way it's written. Now, could we have written y plus 4 is less than x?
Yes.
Only because addition is commutative, right?
Addition's great. That's why we can do it.
Okay. As it is written, I would say in yellow is how it's written. 4 more means you're going to add 4 to something. Could we have written 4 plus y? Yes. But as it is written, 4 more would mean plus 4. 4 less would mean minus 4. Okay. B, the third one. How did you write that? A division symbol or a fraction bar? Fraction bar. Okay. And then the last one, who thinks they got it?
Me.
Who's not me? Ben, what do you got?
2x, 2 plus x minus 5.
What does the word product mean?
Oh, no, it's 2 times x.
So
2x minus 5 is less than or equal to 0.
you got it right.
I was right, yeah.
Are you sure?
He did. Product of 2 and x is written as 2x. Now, if you want to throw some parentheses, Caitlin chose a parentheses, but then she put a plus symbol, but product means multiply. So if you wanted to use parentheses, 2 and a parentheses x, but you have to have a subtract 5. Okay. All right. We think we got a handle on this one. This is objective number 1, which is I give you a phrase and you write the inequality.
Okay.
All right. All right. 3 more reindeer games. Here we go. Next one. Okay. Now you got to pay attention. This may not have been stressed last year. Turns out that a solution to an inequality is, well, it's basically the same thing as it is for an equation. What number makes it true? What number can I throw into the inequality that makes it true? Okay, so if I throw it, any number that makes this true is a solution. So give me a number.
4.
4 makes that true. 1.6 makes it true.
1.6.
1.50 because it's greater than or equal to it. So yes,
5.
how many numbers makes it true?
1.50.
Well, it's 2 true.
Numbers.
Well, not all numbers.
Yes, because it's greater than or equal to.
Yes, but does 0 make it true?
Oh, wait, no, it doesn't.
So it's not all numbers.
It's all.
2 makes it true. -2 makes it false, right? 175 clearly makes it true. And then I can play this game forever. Which one makes it? Unless we listen to what Abby said, which was any real number that is equal to or greater than 1.5. And guess what the inequality says? It literally says that.
Greater than or equal to.
So we got a problem with finding solutions to inequalities. The problem is there's an infinite number of answers. Tonight for homework, they're just going to give you a couple of numbers. You don't have to do it, an infinite number of times. Okay. So the more challenging ones are the ones that are much larger, which you will get. So what's the process? They're going to hand you a number. You're going to see if it makes it true or false. So what do you have to do? So for instance, if I gave you -4, you could do a table of pain.
That's
And
horrible.
technically you are doing one, but most people wouldn't consider this a table. They're just going to plug in the number. So I'm going to take the value -4. They're going to say, is -4 a solution to this inequality? I'm going to toss it into the inequality for the value x and see if it makes it true. All right. Somebody do that for me right there. I mean, do the whole thing. Don't just say yes or no.
True.
I said, don't tell me true or false. Do the whole thing. Tell me what to do.
2 times -4.
2 times -4.
8.
Okay.
Plus 1 equals 9.
Equals what?
-7.
Okay.
And yeah, that's
And then you look at the final statement right there and figure out if that's true or false.
That's obviously false.
Now, the rookie mistake with negatives is what?
Do what I did.
No, that was a different mistake. The rookie mistake with inequalities, the bigger the number, the smaller the actual value. And 7 is bigger than 3, but -7 is not bigger than -3. So the rookie mistake on this is you ignore the negatives, you just look at the numbers. You got to look at the negative values. Okay? Does that make sense?
Yeah.
All right. So on your paper in front of you, box number 3, how many values did I give you?
4.
I gave you 4 values. I'll do one more for you. Does -1 work for this? Let's see. 2 times -1, tossing the -1 in for x. 2 times -1 is -2. -2 plus 1 is -1. And -1, even though 1 is smaller than 3, the overall value of -1 is larger than -3. So this one is a solution. Box number 3, you have 4 values. It looks like this. Go. You can put a T for true and F for false. That'll be fine.
Well, I'm not doing anything.
Kaylin, coming over your paper to see if you got this. Give me a T for true and F for false on your paper for each value. Caitlin.
God. forgot how to multiply and divide.
Ben, don't maybe take it away.
I already know this. I can do the worksheet right now.
You haven't even seen the other two things we're doing.
Yes, I have. I know how to do it.
We're about to find out.
Why don't you take it? That would have been so much fun.
All right, here we go. Around the room. Who do I leave off on? Natalie, first one. True or false? -1. -1, if we throw it in and we do the math, we get the 20 is smaller than 6, and that ain't true, right? All right, Caleb, how about 0?
0 would be F as well.
0 would give you a big fat F for false,
Yep.
because 13 is not bigger than 6. Danny, how about 1? She says 1 is true. Let's see if that's true. 7, it's -7 times 1 is -7. 13 minus 7 is 6. 6 isn't smaller than 6, but it is equal to 6. Therefore, it is true. All right, smarty pants out there somewhere.
Not me.
Tell me something smart before I even ask the last question.
3 is true.
How do you know that?
Because it's big number.
That's not as smart as I was hoping for.
Big number minus big number equals small number.
Okay, it's not necessarily always true, but why did I stop at the value 1 and then I said, tell me something smart?
Because
What was so special about 1?
3 and 7 times 3, but it's negative, which would make it.
Mr. Shuddy, can I ask you a
We
question?
are almost there.
What is
Hold on. Let me finish the point here. Tell me the point I'm trying to make here and why I stopped at 1.
Mathematicians are lazy.
Number larger than it would be small.
You're almost there. Have you got it?
Explain it.
So if 1 is the one that makes it equal, then any number, finish the sentence, would make it always true.
True.
And then any number smaller would have to make it,
Oh,
which is what we found out when we were throwing numbers that were smaller than 1. Hey, 0 is smaller than 1, -1 smaller than 1. We got false and false. Then we found out the magic number that made it equal. So that means any number larger than 1 would have to make it true. Be careful. It's not always like that. It's not always the number larger than the one that makes it equal makes it true. The number smaller. It depends where the negatives in the equation or the expressions are. So it could go either way depending upon what the actual inequality states. But yes, when you find that middle point, then any number bigger or larger ends up being something you don't need to calculate. All right, did that make sense? Okay, that was game number 2. We got 2 more games that Ben says he already knows. So the next game is this, if you remember it from pre-calculus, is we will now be graphing all of our answers when we solve inequalities. So the big deal is, and it seems like a big deal at first, is when you solve inequalities, which will start tomorrow, we have to graph our answers. Because it's not one answer, it's an infinite number of answers. And it sounds like, oh no, we got a graph, and it ends up being that graphing is a very quick and speedy process. Let's see if you remember the process that Ben says he already knows. So let me review first how you graph equations. So if I have this equation right here, x is equal to 3, and for some strange reason I say to graph this on a number line, not on the Cartesian coordinate plane, but just a number line, what do? You just put a dot on 3 and you're done. By the way, pro tip, the dot doesn't go above the number line. It doesn't go below the number line. It goes on the number line as shown right there. Great. How come we've never asked you to graph equations like that on a number line? Okay, because it just doesn't give us any other information. How about that? Instead of saying it's dumb.
No,
right?
it's dumb.
Okay. It's not that it's just not efficient. However, when we get to inequalities, it is the preferred method of stating the answer. So for inequalities, because inequalities have how many answers? Has an infinite number of answers. So for most people, the graphing method tells you more information than just writing the answer, x is greater than 3. Let me explain. I'm sorry, x is less than 3 is what I want to go through. X is less than 3 expresses an infinite number of possible answers. 2, -1, -0.2, 0.2 are all possible answers. But that's hard to wrap your head around unless it's presented visually. All of these are potential answers to that. So if there's an infinite number of answers, well, then we got to present the graph in a different format. So here's how it's done that Ben says he knows. It's going to be a multi-step procedure, which sounds complicated. I wrote the steps on the paper in front of you, and it's not too bad. Step number 1, Ben, is to
Draw a line.
okay, now a line must have, since you're in geometry as well, it must have arrows. So I don't need a segment, no arrows. I need arrows on it. How long does it have to be? Whatever floats your boat. Okay, don't make it too small, but it doesn't have to be too large. Like you don't have to go all the way across the paper. Step number 2, Ben? No, step number 2.
Write the number. That's what it says.
Step number 2 is put a tick mark.
That's below it.
Okay, step number 2, put a tick mark. So I put a tick mark. Where do you put the tick mark? In the center. You are used to number lines where what number goes in the center?
0.
We're not going to be putting 0 at all times. You can put any number you want at the center. It doesn't necessarily mean it's the center of the number line. You're just saying my number in the center is this number. You can choose any number you want. Let's choose smartly.
3.
Guess which number we're always going to choose?
10.
We are always going to choose the number that's in the inequality. So what number is in the inequality?
No, 3.
3. So that's the number that goes underneath the tick mark. I'm not claiming that 3 is in the center of the line. I'm simply saying that's the number that's underneath that particular tick mark. Okay. Now, some math teachers have you put extra numbers. I'm not one of those math teachers. I'm going to claim that by the time you get to high school, you know that give me some numbers smaller than 3.
2, 1, 0, 1.
If I wanted to put those numbers, I would put them to the left of 3. And then to the right of 3, I would write bigger numbers. I am okay with only putting one number. Guess why?
Because we're smart.
Because everyone knows the numbers that are bigger than 3. Everyone knows the numbers that are smaller than 3. In pre-algebra, we usually teachers say put at least 2 numbers to the left and to the right. I'm okay with one number, knowing full well that the number over here is not 2. It appeared 7. I'm pointing to the right. Any number over here has to be bigger than 3, and any number to the left of 3 has to be smaller. Do you understand the idea there? Okay. Next step, Ben.
Open circle.
We are either going to put an open circle or a closed circle. Do you remember this from pre-algebra? And Elise, do you remember what's the parameters for open or closed circle? Like, how do you choose? So she says no. So here are the parameters. If you have this is math words, we call this strictly greater or strictly less than. That means if it doesn't have a line underneath of the greater than or less than symbol, we're going to put what does it say? If it doesn't have a line underneath of it, we're going to put what is an open circle?
It's not colored in.
It ain't colored in. So I'm going to put that symbol right there. Now, when would I put in a colored in circle?
If it was equal to.
We had the line underneath the greater than or equal to symbol, right? If you have a line, that means greater than or equal to. So if you have a line under the greater than or less than symbol, there I said it correctly that time, then you're going to put a closed circle. Closed circle means it's filled in. Hey, I'm looking at x is less than 3. It has no line underneath of it, so therefore I'm not going to put a closed circle. I'm going to put an open circle. Okay, if there's one step that gives students problems, here you got to pay attention. There's one step that gives students problems, it's the last step. We are going to shade either to the left or to the right. Now make sure you pay attention. So here is how you determine. You read the inequality from the letter to the number. Does that always mean we're going to read from left to right?
No.
We're going to read from letter to number. Instead of saying the word letter, like instead of saying X, I want you to say the solutions are, and then read it. So Luke, read it. Instead of saying X, I want you to say the solutions are.
Okay.
The solutions are, oh wait, that one.
Yeah.
So the solutions are, I think that's less than 3.
Okay. So does that mean the solutions are bigger or smaller than 3?
Come on, man.
What does a less than symbol mean? Does a less than symbol mean,
Bigger, which means that number's smaller.
okay, so take a step back. Does this symbol mean bigger or smaller? Less than, it's the less than symbol.
I figured this entire thing out with alligator.
How do you?
Okay, so what is pointing to the X? Big or small number? Okay, you gotta stop. So the solutions are smaller than 3. If it was like this, you'd say the solutions are bigger than 3. So if we read this from variable to number, the solutions are, you're either going to say bigger or smaller than the number. And Chris, or you just said that the answer was?
The solutions are smaller than.
And you just told me I don't need to write any extra numbers because you know where the numbers are. So which side am I going to shade, left or right? Where are the solutions smaller than 3?
The left.
Left side. So how do you shade? Okay, if you're like me and you're lazy, you go wiggle, 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 and you put an arrow. Okay,
Yeah.
that means that this includes all the numbers except for 3 that are smaller than 3. If it was a closed circle, guess what it would mean?
Any number including 3.
Any number including 3 that's smaller, right? Does that make sense? It's the shading that usually kids have a problem on. And I just want you to read it from variable to number. And instead of saying the word less than or greater, is saying smaller than or bigger. Greater would be bigger. Less than would be smaller. All right, let's do that again. All right, there's my inequality. Step 1, draw a number line. Easy. Step 2, put a tick mark in the middle. Step 3, put the number underneath the tick mark. What's the number?
1.
So the number is 1, so I put a 1 right there. I'm not claiming 1 as a center. I'm just saying it's the number 1. Now read it from variable, Gavin, read it from variable to number.
And
The solutions,
the solutions.
just read it.
And
No, instead of the word N or the letter N, I want you to say the solutions.
the solutions are less than,
Instead of saying less than, I want you to say bigger or smaller,
are bigger than 1.
because that's the bigger than symbol. So what's the smaller than symbol?
It points the other way.
You got it backwards. From the previous slide, you told me you knew what that symbol was. That is
Smaller than.
that's the less than symbol. So that means smaller than. That means N is smaller than 1, right? That means the solutions are smaller than 1. So where are the numbers? Oh, I'm sorry, open or closed circle?
It's closed. No, open.
Which one? You said both.
Open.
Open, because it doesn't have a line underneath it. So where are the numbers that are smaller than 1?
To the left.
To the left. So that's what we're going to do. Shade to the left. The solutions are smaller than 1. N is less than 1. It means exactly the same thing. If you don't want to say the word solutions, you can say the letter, but the letter means the answers. The answers are smaller than 1. The answers are less than 1. Does that make sense? All right. One more time. Here we go. Ready?
Sure.
All right, Luke, first step.
Well, we draw the number line. And
Step 2.
put a tick mark.
Step 3.
Right number that's 0.
Hey, we finally got 0 in the middle. Okay. Notice the tick mark in this case would be the middle, right? All right. Open or closed circle.
Closed.
Why closed and not
There's
open?
a little line.
Because there's a line underneath the left or the greater than symbol. Now, when you read this, instead of A, I want you to say the solutions are.
The solutions are greater than.
That means bigger.
Or equal to 0.
So where are the numbers that are greater than or bigger than or equal to 0?
They are right.
And that's why you're going to shade to the right. Does that make sense?
Yeah.
Okay. There's a big but here, and the big but is this.
Mm-hmm.
We said this could be flipped around, right? So how would I flip this around? The yellow part.
Completely write it
Everything.
backwards.
So tell me what I would write if I flipped it around.
0 is less than the
Or equal to.
or equal to whatever.
But when I said to read this, how did I say to read this?
Letter to number.
I said letter to number. So I'm on the bottom here, period 7. So if I read the bottom one here, I'm not going to start with 0. I'm going to start with A. And it would now read A is bigger than or equal to 0. So the answers are bigger or equal to 0, it's read the same way. So even though I flipped it around, they will do that tonight for homework. They're going to flip it around. You have to read from letter to number. I don't care if it's on the left or the right. You have to read from letter to number. Does that make sense? Yeah, if they're nice to you, it's going to be like the top one. If they're not nice to you, it's going to be the bottom.
If they have it like the bottom one, just make it the top.
You could do that too. You could do that too. All right. Did you hear what he said? He's like, if I get confused, I'm just going to flip it around for myself to make it less confusing.
Yeah.
All right, here we go. Grab your pencils. This is box number 4. Box number 4, Kaylin. Kaylin. Box number 4. Grab your pencil. Let's go. Read the steps, Kaylin. Everybody do the steps as he reads them out.
Draw a number line.
Draw a number line. Next step. That's not what it says. Put a tick mark.
No, it said.
Is there a mistake on the sheet?
Yeah.
Okay. It should say put a tick mark next. So put a tick mark. Next step. What's the number here for the first one?
-3.
So I put -3 underneath the tick mark. Kaylin, open or close circle? Open circle. Now shade to the. This says F is
More than.
bigger than. Where are the numbers that are bigger than -3? Kaylin, you're pointing to the right and you're saying the word left.
This is not the right.
Agreed. So you're saying the numbers on the number line that are bigger than -3 are to the left. This is what you did with your hand when you said the answer. Right. All right. So there's your answer. Yes? Okay. Carly, do the second one. Draw a number line. Keep going. Tick mark goes in the middle. What's the number in this one? -2. Am I going to put an open or closed circle? Closed circle. Okay. When I said to read it, I said to do it in what order? I said from letter to number. So if I go on the yellow one there, if I go letter to number, I'm going left to right. On the green one here, if I go from letter to number, I'm going from right to left. So the answers are smaller than -2. Where are the numbers, right? Left or right? Where are the numbers that are smaller than -2? To the right or to the left? To the left. So there's your answer. Ben, yes? We got one game left. What's the game?
The opposite of what we just.
We just got to do the opposite. So what am I going to hand you?
The line, the graph.
I'm going to hand you the graph. You're going to write the inequality. That's the last game of the day. Last game of the day. I'm going to hand you the graph. You're going to write the inequality. So it's just flipped around, reverse. Get it? Luke, stop.
That's not reverse.
That the second one was.
Maybe.
All right, here we go. So hopefully I didn't screw this up. The steps are step number 1. Cohen, read. There's my graph. I'm going to write the inequality. Step number 1. What's it say?
Pick a letter.
Pick a letter. Any letter. It doesn't matter. Pick a letter.
X.
Pick a letter. I chose G.
Q.
Okay. But you can choose any letter. A lot of kids just always choose X, and that's perfectly fine.
Oh.
Second step.
Write the number.
Hey, there's only one number here. Now, granted, tonight for homework, they're going to give you a full number line. Guess which number you're going to write? The one that's underneath the circle, either open or closed. Right? That's the number you're going to write. What's this number, Cohen?
13.
So I write a 13. Now we have to decide whether or not it's an open or closed circle. Is it open or closed?
It's totally open.
It is totally closed. So here's the deal. Period 7, you can't see this. I'm circling what it says there for closed circle. So here are your two options for symbols. Right? I'm circling the period 7, I'm circling the two options for closed circle. So it's either one of those two inequalities. Which one is it? You need to go back to the graph. Is it pointing to the numbers that are bigger or smaller than 13? Where's the graph going? It's going to the left, and those are the numbers that are bigger or smaller than 13.
Small.
So which symbol that I just circled says smaller than?
just said less than.
I know you did, but I'm trying to drag it out a little bit. So I'm going to pick the correct sign, and that's the correct symbol. So how did I pick that symbol? I looked at where it was shading. I always get one smarty pants kid that says this. Go ahead and say it, whoever that kid is. I know how to pick the symbol.
The number, the way it goes.
Somebody is going to say it was Ben. It says you just pick the symbol that's pointing in the direction that's shaded. Is that always true?
Yes.
As long as, who can figure that one out?
You're going number to letter.
I'm going letter to number. Notice, letter to number, then that will always work. But what happens if the G is on the right side and the 13 is on the left side? Then it would be reversed. So yes, I know, that's why this points in the direction of the shading. But if I were to instead write 13 and G period 7, I wrote 13 on the left and now G on the right, then it would be that symbol and it would not point in the direction of the shading.
What it does, the alligator goes that way. The on arrow way.
If this was an arrow, if this was an arrow, then the arrow is pointing to the left. Right?
If Chris was an archer,
And this is
he'd
what-
shoot behind him.
This is what Ben was trying to say. So Ben, summarize what I just said.
So whenever it's variable number, then the sign will point.
It will, and it will whichever way it's shaded, that's the way it points. Just be careful. That is a simple mistake, and math teachers will love to write it backwards, and you'll get it backwards.
I'm gonna do
All right.
it my way.
Here's another one. Here's another one. All right, here we go. Nick, you haven't done one yet.
It would be
Pick a letter, any letter. He likes X. I picked G.
X is
I always pick G because everyone wants me to pick X.
X is greater than.
No. Next step. I know you're going to get it right, but next step.
20.
What's the next? I picked the letter. I picked G. Next step. I write G. Now what do I write?
Greater than.
I write the number. Okay. Now you look at open or closed circle. What do we got? We have a closed circle. So that means it's one of these two symbols. Now, how do you determine? Either Ben's method or the reading method.
Or my method.
What was Ben's?
Okay, Caitlin, you need to use the reading method. The reading method is this. Is this saying the answers are bigger or smaller than -1, Caitlin? It's on your paper. Oh, actually, it's not. Sorry. Is this saying the answers are bigger or smaller than -1? So which one of these says bigger? The one on the left or the one on the right?
The left one.
That says smaller.
Oh.
Because this is the less than or equal to symbol. This is the greater than or equal to symbol. So I'm going to pick that symbol because that's the greater than symbol. And you just told me that the answers based upon the shading are bigger than -1. So that's the non-Ben method. I'm going to say the Ben method, but you got to be careful. You're going to screw this up. If it doesn't go letter number, then it doesn't point in the same direction. So if I write -1 on the left and G on the right, then the inequality is going to be flipped around.
And the alligator is gonna go this way.
So now the arrow is pointing to the left when the arrow is pointing to the right. Does that make sense? Okay.
Alligator.
All right, you got one box in front of you, and that is box number 5. You got 2 problems. Write them down.
Survive. What
Um,
is that?
I thought it was going to be 6, but it's 5.
Uh-huh.
Survive.
All right.
I do the alligator
Like
method.
right now. Can we get our work tape?
Yes, let's finish this up.
Bend the letter, and then the alligator is the way the arrow goes.
Do your paper. Do your paper, Caitlin. Everybody done?
Oh yeah.
All right. Here are the 2 answers. We're done. Before you walk out, go over there and grab yourself a worksheet. Is in the box. Period 7. I need someone to hand out the worksheets. That is it for today.